Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 512. So I'm going to first start by factoring out 4 to the power of x. So now I have 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 512. Now if I simplify what's in the parentheses, I get 4 times 4 to the power of x is equal to 512. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 times 4 to the power of x, well 4 is the same thing as 4 to the power of 1. So 4 to the power of 1 times 4 to the power of x, that's going to equal 4 to the power of x plus 1, and this is equal to 512. Now, 4, this is the same thing as 2 squared. So I have 2 squared to the power of x plus 1 is equal to 512, which is the same thing as 2 to the power of 9. And if I have something from a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x plus 1, it's going to equal 2 to the power of 2 times x plus 1. And 2 times x plus 1, I can simply distribute the 2, so I get 2 to the power of 2x plus 2 is equal to 2 to the power of 9. Now if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x plus 2 is equal to 9. Now if I subtract 2 on both sides, I get 2x is equal to 9 minus 2, which is 7. And if I divide both sides by 2, I get x is equal to 7 over 2. Now I'm going to go ahead and check if this is right. So to check, my original equation was 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 512. Now if I plug in 7 over 2, I get 4 to the power of 7 over 2 plus 4 to the power of 7 over 2 plus 4 to the power of 7 over 2 plus 4 to the power of 7 over 2 is equal to 512. Now 4 is the same thing as 2 squared, so I have 2 squared to the power of 7 over 2 4 times is equal to 512. And these two cancel out, so now I have 4 times 2 to the power of 7 is equal to 512. And 2 to the power of 7 is 128, so I have 4 to the power of 128 is equal to 512. And 4 to the power of 128 is 512. So I have 512 is equal to 512. And because this is right, my solution here is right. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So I'm going to first start by factoring out 5 to the power of x. So now I have 5 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1,000. Now, if I simplify what's in the parentheses, 1 plus 1 plus 1 plus 1, that's 4. So I have 5 to the power of x times 4 is equal to 1,000. Now I can divide both sides by 4. So then these two cancel out, and now I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. Now, 250, I can rewrite this as 25 times 10. So I have 5 to the power of x is equal to 25 times 10. And 25, that's the same thing as 5 squared. So now I have 5 to the power of x is equal to 5 squared times 10. Now what I'm going to do is I'm going to take the log on both sides. So now I have log of 5 to the power of x is equal to log 5 squared times 10. And now an important rule to note down is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x, and we can think of x as being this case. So I can simply move x to the front. So now I'm going to have x times log 5 is equal to log of 5 squared times 10. Now, we obviously want to find the value of x, so to do that, we're going to have to isolate it. And to isolate x, we're going to have to get rid of this log 5 by dividing both sides by log 5. So then these two log 5s cancel out, and then I get x is equal to log 5 squared times 10 over log 5. Now if I have something in the form log a times b, this is equal to log a plus log b. So log 5 squared times 10, that's going to equal log 5 squared plus log 10. Now I have this over log 5. Now remember how if I have something in the form log AB, I can move this to the front. So now I have x is equal to 2 log 5 plus log 10 over log 5. And log 10 is equal to 1. So I have x is equal to 2 log 5 over log 5 plus 1 over log 5. These two cancel out, so I get x is equal to 2 plus 1 over log 5. Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to start by taking the log on both sides. So now I have log of 4 to the power of x is equal to log of 40. Now, if I have something in the form log of a to the power of b, I can move this exponent of b to the front. So this is going to equal b times log a. So in this case, I have log 4 to the power of x, and I can move x to the front. So now I'm going to have x times log 4 is equal to log 40. Now I'm going to go ahead and divide both sides by log 4 so we can isolate x. So then these two log 4's cancel out, and I'm going to be left with x is equal to log 40 over log 4. Now we can rewrite log 40 as log of 4 times 10. And if I have something in the form log of a times b, this is equal to log a plus log of b. So log 4 times 10, that's going to equal log of 4 plus log of 10 over log 4. And if you guys already know, log 10, that's actually equal to 1. So I have x is equal to log 4 plus 1 over log 4. Now, I can rewrite this as log 4 over log 4 plus 1 over log 4. Now log 4 and log 4, these two cancel out. So I have x is equal to 1 plus 1 over log 4. Now log 4, this is equal to 0.602. So I get x is equal to 1 plus 1 over 0.602. And 1 divided by 0.602 is 1.66. So 1 plus 1.66 is 2.66.